Welcome back. It's been a long time. So let's continue with trigonometry. So trigonometry is all about angles. Okay. So an angle, what you have to understand is it can be measured either in degrees. An angle can either be measured in degree or it can be measured in what is called rad. So an angle can either be measured in degree or it can be measured in radian. All these ones are measurements of an angle. But before we get to these ones, we need to understand what are we talking about. What's the relationship? So what you have to know is an angle is so much related to, we talk of, the circle thing, the circumference and everything. Okay, so let's start with, let's say we have got a circle, a unity circle. What do we mean when we say a unity circle? So when we mean a unity circle, it's a circle with radius 1. It's a circle with radius 1. All right, so let's get this unity circle. Okay, so we have that unity circle, but let's attach it some some compass, some y and x axis. It will help us to understand one or two. So when we are saying that this is a unity circle, it means any radius within this circle, it will be 1. Okay, now from this unity circle, let's have a let's mark somewhere there. Let's say we can mark somewhere over there, like that. That's our point somewhere there, and then we can say, well, this point should be P. Okay, now if you, let's say we have a radius, remember this radius will be 1, right? Okay, and so we have our point P, and then our bottom here we have got our point A. Okay, so why are we doing that? So that we should have what is called an arc. Okay, we should have what is called an arc. That one, that's an arc, and this an arc is arc AP. All right, so over here we're going to have what is called a theta. You see, we form something like an angle, but let's not get ahead of ourselves. So what you have to know is, for me to be able to get this angle, or to be able to know what kind of an angle is that, is I need to make the use of the relationship that exists between this arc length, the arc length. Let me show you. I need to be able to make the use of the relationship between this arc length AP, and this whole circumference. Okay, if I am able to understand the relationship between these two, then I'll be able even to get to that angle. All right, now, so how? Well, so what we're going to know is that if I want to find that angle, I can say that theta is equal to, that's theta, that angle there, it will be equal to the length of the arc. I'll just be writing it as an arc. Length of an arc will be equal to length of an arc AP over the whole circumference. Okay, over the whole circumference, which in this case, I'll just say circ. Okay, so that's what I'm talking about. So if, and then you multiply this by 360 degrees if you want your answer to be in degrees. Why am I saying if I want my answer to be in degrees? Anyway, don't worry about it. Okay, so what we are saying is, for me to get an angle that has formed, this arc, all I have to do is to divide this arc over the whole circumference, and then I multiply that with 360. So if I multiply that by 360 degrees, so whatever I'm going to get is going to be the angle of that the angle which that arc is forming. All right. Now let's get this one thing straight. All right. Let's get this one thing straight. How do we find the circumference? Okay. How do we find the circumference? So we understand that circumference, just denote it as, we understand that a circumference circ is equal to 2 pi r, right? But then this is a unity circle. A unity circle, we say that the radius is 1. So that means this will become 2 pi 1, which is equal to 2 pi. So that means the total of this circumference is the same as 2 pi. So this is where now the pi is coming in. Because what I'm saying is, for me to be able to find the theta, all I have to do is to be dividing. All right. Now, let's get this one thing as well. Now, let's look at this one now. Let's say, like the way how it is. Suppose my P, I have shifted it. It's now no longer where it's supposed to be. Suppose I have shifted my P, or let me have another one. Let me have, what should I have? Let me have Q. Okay, and the Q is the point on that one. So let's say my arc has changed. My arc is no longer P, but it's Q, which is from here to there. Okay, 1/4 of this, because there are 4 of them. So let's say it's 1/4 of my circumference. All right. So suppose my I want to help me to get what would be the value of this angle. If my theta, if my arc is from here up to there, okay, if it is this part, what would be the angle? Okay, so what I have to know is that my arc length there, my arc length is equal to 1/4 of the circumference. Why am I saying the circumference? Because look here, this is 1, 2, 3, 4. So it's 1/4 of the whole circle, which is the whole circumference. So let's say it will be now 1/4 times the circumference. Now that arc length, okay, times the circumference. And this circumference, we already know it's 2 pi, right? Okay, so what does that gives us? This gives us what? So this is 2 pi over 4, which is equal to 2 there, 2 there, and there. So we have got pi over 2. Okay, so what we are trying to say is what? All right. Now, my arc length, what I was trying to say is, what if my arc length is no longer at P, it's at Q, okay? So it's kind of like I've shifted it. I hope you're still able to see, because this beginning is very, very important, okay? It's very, very important. So this is my point A, and this is, remember, my Q here. So what I've done is I've shifted, whereby it's no longer here, but I've kind of added it so that it be the whole of this. You see, the whole of this. So this is just 1/4 of the whole circle. So the arc length is the same as 1/4 of the circumference. Okay, that's why I have here 1/4 of the circumference is equal to 2 pi over that, and is equal to pi by 2. That's just arc length. So for me to find the theta here, from this formula, we're saying the formula is arc length over circumference. But here it will not be AP, it will be AQ, right? So that means A theta will be equal to arc length, in this case, we're talking about AQ over circumference, circum. Okay, so what's my arc length? I've found, but then here we said you need to multiply by what? By 360. Okay, so that you should be able to get the angle for that one. Okay, times 360. All right, so what's my arc length? So because I've shifted, it's no longer repeats at q now, and at q is same as 1 over 4th, so which is pi by 2. So my arc length there is pi by 2 divided by circumference, which is 2 pi, times 360 degrees. Okay, so my theta, this new theta I'm talking about, this one, okay, then it's going to be is equal to here pi over 2 by 2 by 2, I mean sorry, pi over 2, this pi and the pi will get cancelled. I hope you're able to see that, right? So here we're going to get, okay, let me just, this is same as pi by 2 divided by 2 pi, which is divided by 2 pi, remember, divided by 2 pi, which will just be like times, anyway, I just want to show you, okay, because the answer here is 90 degrees. I just want to show you how I'm getting there. So we can change this into this symbol, divided by 2 pi times 360, but I know that this is the same as pi by 2. That changes to multiplication, becomes 1 over 2 pi times 360. This and this cancels. 2 times 2, 4. Then it becomes 360 divided by 4, which is 90. All right. So what I'm saying is, so yeah, that's 90. So what are we saying? What we are saying is there is a relationship between an arc length and the angle at which it forms. So when I changed my arc length from P where it was to Q, then the angle became 90. The theta there is 90, which means if I wanted to find the other one, if this one was the middle, if this P was on the middle, then it'd be 90 divided by 2, which means it'd be 45. Okay, what about if now I have another point, let's say R here. So I want to find this arc length. I want to find this now. Okay, not this arc length, but the angle that which this one forms. Because what I was doing was I was finding an angle which this one forms, and we have found it that it is, sorry, the angle which this one forms, and I found it that it is 90 degrees. What about if I continue to this? What kind of an angle does it form? All right, so it will be the same thing which I did. So first of all is you go back to the formula, whereby the formula says theta is equal to arc length over circumference. Now, what's the arc length? So to find the arc length is we use these quadrants, okay? We use this one is 1 over 4. This one is 2 over 4. This one is 3 over 4. And this one is 4 over 4. You see, it's just like that. Because it's fraction. 1/4, I mean 1/4, or a section out of 4 sections. So this one, this arc length, this one is the same as 2 over 4 of the entire circumference. Okay, so from that one is where it'll be now the arc length. We want to find the arc length AQ, AR. That one is the same as 2/4, which is just half. It's half of the entire circumference, which is 2 pi. And then here you divide, you find your answer pi, which means from the formula of theta equal to arc length, I'm going to put pi, over circumference, I'm going to put 2 pi, times 360 degrees. What am I getting? This cancels, that cancels, and gives 180 degrees. You see? So if I move from this part and then I go to that part, I'm getting 180 degrees. If I move just to that, I get 90 degrees. So you can do again with here if you have another point there is, and then you can also find what an angle does it form if an arc runs from A to S, like this, A up to S, what an angle form. So we're going to be, it will be now 3/4 of the circumference times 2 pi. And then you solve like the way how we have done it. At the end of the day, you're going to get an angle there. It now be 270 degrees. So here we have now learned that from the length of an arc, we will be able to know the angle at which it forms, and that angle in degrees. So this is the measurement of an arc in degrees, or the measurement of an angle in degrees. But like I said from the start of this lesson, like I said also, that an angle not only can it be measured in degrees, but it can also be measured in what is called radians. Okay, so let's now go to the other part, whereby we'll now be looking at the same angles. So, okay, before I go further, so we have seen that if I've got a circle, okay, or we have seen this, that from here to here we get 90 degrees, and from there to there we get 180 degrees. And I said if you continue with that, from there to there you get 270 degrees. From there to there we get 360 degrees, because we have been learning this. Okay, we have been learning this, but we didn't know where these figures were coming from. But today we have learned that it's just a matter of the relationship that exists between an arc length and the circumference. That's all. So it's about an arc length and an angle that is formed in between of that. Okay, so that's what we have seen now. That's what we have learned. But then I wanted you to also learn about angles in what is called radians. Okay, so we'll also learn about angles in radians. Now, an angle is in radian if theta is equal to length of the arc. Okay, how are we getting there? So we are saying an angle is in radian if theta is equal to length of the arc. So if the theta is the same as the length of the arc, then we say that that angle is in radian. For example, the one whereby we said that from the beginning, whereby we had, let's have that one. So this I'm going to do it roughly, like really roughly. I don't want to get an award from this. It's going to be a very rough week. Yeah, but quick. Whoa. Okay, so we saw that if this is an origin, so let me choose a different ink. Okay, so this is point A. So if I said that at first it was here, my point, right? And then I moved it there. So I said if it is like this, what was the length of the arc here? So we said that the length of the arc, so we said the length of the arc there will be equal to, this part is just 1/4, right? It's just 1/4. It's 1/4 of the entire circumference, which is what? 1/4 of the entire circumference, which is 2 pi. And what was the answer? The answer, the length of this arc was pi by 2. Okay, it was pi by 2. You remember this one, right? So we said the length of this arc is pi by 2. So what we are saying is an angle it becomes now in radians if the theta is equal to the arc length. So in other ways, from where we have here this AP, then it means this angle in radians, okay, that angle in radius, this angle you are talking about there, it will be theta is equal to, it means then that angle in radius is pi by 2. Just put the word here, rad. That's what it means. Similarly to the one we saw, okay, this is when it is point P. Okay, so what you have seen there is that here in radians, we equate that theta is equal to arc length. Whatever you get in arc length, that's your theta. So there, how we are getting the arc length was just making the use of that this one, the length from here to here is 1/4 of circumference. And if we continue here, is 2/4, which is the same as half. And to here is 3/4, and to here is 4/4. Of what? Of 2 pi. Of 2 pi. So we had another point, which was here. I think we named it, was it R or Q? Anyway. So if this point is there, then we are looking at this arc length. So we said that one, it's 2/4, right? So it'd be like theta is equal to 2/4 of pi, 2 pi r. It's like 2/4 of 2 pi, right? And then we say this is the same as half times 2 pi, which is the same as pi. Then it means when it is here, now from what we are solving, we solved that if it is just at point P, it means there's a lot of mess here around here. We say if it is at this point here, this one, the angle it formed was 90 degrees, and the rad we are saying that it is 2 pi by 2. So whilst here we said that we found out that to be 180, but here we found it to be pi. So it means pi here is equal to 180. This is pi rad, remember. Maybe you forgot it. This is what we were doing. Have you seen? We found the first one, yes, 90 degrees, but there we found it to be what? Pi by 2. Pi by 2 rad. In rad, that is pi by 2 rad. And here we found it to be 180, but here we found it to be what? Pi rad. So you can see there's that relationship. So using that relationship, we can also establish our own relationship, whereby we can say that 1 pi rad is equal to 180 degrees. Therefore, to get 1 rad, you divide both sides by pi. You divide both sides by pi. Therefore, 1 rad is equal to 180 degrees divided by pi. So you can use this conversion, anything, to convert from radians to degrees. What about to convert from degrees to rad? Well, it's pretty much the same, okay? Because we said 1 pi rad is equal to 180 degrees. Then it means angle in degree. So you can see there, we have another one where we have said 180 degrees is equal to 1 pi rad. We can remove that 1 pi rad. You can see pi rad. So here you can divide both sides by a 180, but for now let's just leave it there. Okay, so let's now do some of the examples, whereby in these examples of course here you can also proceed by dividing Okay, anyway, I already did. Okay, let's have now examples. Now, in these examples, we have been asked in these angles is we have been asked to change the following angles from degrees to radians. So to change the following angles from degrees to radians. The first angle we are to change is 45 degrees. Okay, so how do we do that? Okay, let's do it on the fresh page. So we want to change 45 degrees to radians. But what is the formula? So remember from this one, we have said that 180 degrees is equal to pi rad. So we can use that one. So 180 degrees is equal to pi rad. How about 45 degrees? Which one is bigger? Between 45 and 180 is 180, right? So it will be less. So because it's less, it will be 45 over 180 times pi rad. So 45 into here, 1 into this one, 4. And then the answer you're going to get will be pi by 4 rad. So 45 degrees is the same as pi by 4 rad. And another one we have been asked is to convert negative 57 degrees. Still the same way. This one will be 180 degrees is equal to pi rad. Then negative 57 degrees got to be less. So it will be negative 57 degrees over 180 times pi rad. So if you can see here, then the answer is, because there's nothing can go into, of course you can divide, but would like to leave it like that. So if I convert that, I get that. So it means from now there, I have now learned how I can change my angle from degrees to radians. Here you can change anything. Let's try something new. Maybe let's try 120. Let's try, okay, what about, someone can say, what about if it is 270? All right, let's try 270. Something, oh yes, 270. 270 degrees. Well, it'll be the same. You say 180 degrees is equal to pi rad. What about 270? It's gonna be more because it's bigger than 180. So it's gonna be, it's always on top, the one you are finding. It's always on top. 280, 270 divided by 180 times pi rad. Okay, so what do you get here? Well, 27 into 3 goes, I mean 20, what did I want to say? 9 into 27 goes 3, and there it goes 2. So it means I'm going to have 3 by 2 pi rad. So instead of writing 270 degrees, I can just write 3 by 2 pi. That means I've written 270 degrees. Instead of writing 90 degrees, I can just write pi by 4 rad. Instead of writing 180 degrees, I can write pi rad. What about 360? What's 360? Okay, so let's try 360. So 360 degrees it's gonna be, okay, let me say 180 degrees is equal to pi rad. So we're looking for 360. It's gonna be more. So we have 360 over 180 times pi rad. So this goes 2. So the answer there is be 2 pi rad. So instead of writing 360 degrees, I can write 2 pi. So from what we have learned now is we have learned that the common angles like 45 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Their counterparts, this one is pi by 4 rad, and this one is pi by 2 rad, and this one is pi, and this one is 3 pi by 2, and this one is 2 pi. Please, you need to memorize these angles just as in the same way you memorized these angles. All right, so let's now try another example. And in these examples, we'll be converting from radians to, yes. So convert example 2. So here we've been asked to convert the following from rad to degrees. So you need also to master the conversion that takes place between radians and into degrees. You have to master it. So the first one is pi rad. Okay. No. Sorry. The first one is 3 rad. Okay. The first one is 3 rad. So how do we do that? Remember, we had these formulas, right? We said 1 rad is equal to 180 degrees pi. Oh. Okay. So if 1 rad is equal to 180 degrees degrees pi, then what about 3 rad? It's gonna be more, right? Yeah, then it's gonna be 3 rad over 1 rad times 180 over pi. So the rad and the rad get cancelled. The answer there will become 3 times 180. Let me get my calculator. Yeah. My brain is not that, So it becomes 540 degrees over pi. Okay, so you see, I've now removed that rad thing. Okay, let's look at the other one. The other example is you want to convert pi by 10. That's B, pi by 10 rad to degrees. So you do the same thing. Okay, so we said 1 rad is equal to 180 over pi. But remember, this formula is also the same as, again, my brother says by pi, right? So that it becomes pi rad is equal to 180 degrees. Now I'm going to use this one because in my question here, there is pi. This is different from the first example. There was no pi, there was just a rad. That's why I used the 1 rad is equal to 1/8 over pi. But because in my question there's a pi, it's better to use the pi rad is equal to 1/8. So if pi rad is equal to 1/8, what about pi by 10? It's gonna be raised, right? I know. It's gonna be pi by 10 divided by pi times 180 degrees. This is gonna be pi by 10 times 1 over pi times 180 degrees. This cancels that it gives us 18 degrees. So you can see now the difference. So this is how now you can convert from degrees to pi rad. So if you are able to understand that, then it should be much easier for you to solve any problem that regards to conversion between radians as well as the thing we have to learn is about arc length and area of a sector. Need to learn about arc length and area of a sector. Okay, suppose I have this circle. Okay, and then let's say I've got center. It's a circle, could be a unity circle, yes. A circle with center, but okay, anything. Center O, no, sorry. Center O, and then let's have a point there. That's being point B, and here point A. Okay, so it means I've got your sector, and then we have got our radius here. So to find the length of the arc, so we say length of the arc let's say you want to find the length of the arc. In that case, AP, it will be equal to theta it will be equal to theta. Okay, it will be equal to theta times radius. So that's how you find the length of the arc. So to find the length of the arc, it's theta times radius. That is, if you are given radius. Because remember, we said earlier that in a radians is whereby a theta is equal to what? Is equal to a arc length, right? So in that case, we had the length of the arc, and that we had a unity circle whereby r was 1. So the length of the arc was indeed equal to the theta. So what we are saying is, given any radius, then the length of the arc will be equal to theta times radius. Okay. Whilst the area of the sector, what's the sector? Sector is a region that is formed between two radiuses and the arc length. So two radiuses and arc length. So this is the arc length we're talking about. Two radiuses in between. So that means we're talking about this area. Okay, that's now your sector. So to find the area of a sector, we use a formula whereby we say area of a sector is equal to So area of a sector, it's now equal to theta over 2 r square. Okay, so that's now but you have to know that both in here and in here, when you are trying to find the length of the arc and the area of the sector, you need to make sure that the angle is in radians, not in degrees. So that's how it is, like, you know. So let's have an example from this one. So example, in this example is we've been asked to find the area of a sector of the circle subtended by, okay, we're going to find both. Okay, so let me write the question. All right, so we have got this example whereby they're saying find the arc length in the area of the sector of the circle defined by the angle 45 degrees at the center with radius 6. Okay, this could be anything, could be 6 meters, but here I've just said radius 6. So what you do is want to find two things. Want to find the arc length and want to find the all right, so A is we are finding so A is want to find the arc length. Okay, so remember the arc length we said is equal to theta times r. But what's our what's our what? What's our what's our theta? But our theta is in degrees, so we say you have to convert it to be in radius. So we're going to say we know 180 degrees is equal to 1 pi rad, right? So how about 45? So we already know that 45 is the same as what? Pi by 4, right? So it means the arc length, answer for the arc length will now be equal to pi by 4 rad times times 6 for 6 units, I mean for the radius, because they haven't indicated the measurement. If they had indicated the meters, we would have put 6 meters, but it's just 6. So then 6 times that one becomes 6 pi by 4, which is equal to 3 pi by 2 units. So it means our arc length is equal to 3 pi by 2 units. That is, if it was meters, we would have written meters. Okay, and then B is want to find the area of a sector. Area of a sector. So area of a sector, we said so area of a sector, we said that it's half theta what? R square. But then what are you seeing here? What we are seeing here is theta r square. You can see this is the same as, okay, it's just to make things easy. Theta r, you see, the whole of this one times r. So we have already found theta r, that's arc length. So okay, that's what I'm seeing here. Okay, but theta r is the same as the one we have found, which is what? 3 pi by 2. You just have to find the half of this one. Okay, just have to find half of this one. So it's going to be half of theta r, that's the arc length, which is 3 pi by 2 times r, which is 6. Okay, so here we're going to get that's 4. Okay, so 2 into that's 3. 3 times 3, 9. That's 9 over 2. So we're going to get 9 pi by 2 units. So I've solved like this is because I started with finding the arc length. But if I had not found the arc length, then I would have just maintained it as it is. Okay, so which means oro, that's one way to solve it. Oro, all I could have done was to say, well, it's half theta r square, right? What's my theta? My theta we found to be pi by 4. So it would be half and then pi by 4 times r square, which is 36. Okay, and then when you elaborate this becomes now pi by 8, and here you have got 36. So 4 into here 2, 9. So is 9 pi by 2 square units. Yeah, so here it's not just units but square units, because we're talking about area. So that means if it were meters, then it would be 9 pi by 2 square meter. That's what we mean when we say square units. All right, so we have really covered a lot, as we have now appreciated on how we can solve that and how we can also do that. So next time we'll now look at I think we can finish before we go to negative functions. Okay, let's now let's stop there for now. Thank you very much for your attention, and we'll continue from there next time.